we discuss about rate of a convergence of a Newton-Raphson method. So Newton-Raphson method, what is the iterative scheme of a Newton-Raphson method? As in a previous lecture we discussed about iterative scheme of Newton-Raphson method. Iterative scheme of a Newton-Raphson method, first we write down about rate of a convergence of of NRs in a sort called Newton-Raphson method. So, what is the iterative scheme? Iterative scheme is a what? Xn plus 1 equal Xn minus f of Xn divided by f dash Xn. Now, again, suppose alpha is the actual root, alpha is the root of or solution, one solution of fx. Then obviously f of alpha equal to what? F of alpha equal to 0. And if we define the error after nth iteration, positive difference En, this was a positive difference, En equal mod of Xn minus alpha, error after nth iteration. So we simply, this one is a positive difference. If we consider only a positive difference, then what is the value of En? En equal Xn minus alpha. So what is the value of Xn? Xn is alpha plus E. Similarly, what is the Xn plus 1? Xn plus 1 is alpha plus En plus 1. Now, if alpha plus E plus n, now if we put these values Xn and Xn plus 1 in the iterative scheme of a Newton-Raphson method, now what is the expression? This becomes alpha plus En plus 1, the value of Xn plus 1, now here alpha plus En minus f of alpha plus En divided by f dash alpha plus E. Now, using the Taylor-Series expansion, what is the Taylor-Series expansion? Already we discussed this one. F of A plus H is a what? F of A plus H, f dash A plus H square upon factorial 2 f double dash A, and so on up to infinite number of terms. Now, using the Taylor-Series expansion, this becomes what? Alpha plus, and this alpha cancel out, and what is the value? This becomes En plus 1 equal En minus, here we write two terms with the help of a Taylor-Series expansion. This becomes what? F of alpha plus En f dash alpha plus En square by 2 f double dash alpha. Only we write two terms and ignore all other terms. And in a denominator, f dash alpha plus En f double dash alpha plus En square, only we write a two term, not more than two term. After triple dash alpha, there is no need to write a triple dash alpha because we ignore the second onwards all of the terms. So here it is. So if we simplify this one, then obviously En plus 1 multiplied by this one, so En plus 1 become what? Here we multiply En f dash alpha, En f dash alpha plus En square f double dash alpha, and so on. Since we multiply En by this one minus this term. F of alpha becomes 0 because alpha is a what? Alpha is our actual root. So this becomes minus En f dash alpha plus En square by 2 f double dash alpha and so on, and divided by what? Divided by this one, f dash alpha plus En f double dash alpha. So here, if we consider this one, En f dash alpha cancel out with the En f dash alpha, En square f double dash alpha minus En square by 2 f double dash alpha. Now this expression become what? This expression become En plus 1 equal 1 by 2. If we simplify this one, 1 by 2 En square f double dash alpha. In a denominator, this one is a what? This one is a f dash alpha plus En f double dash alpha. If you only consider the first term, or we write f dash alpha is a common. So 1 plus here f dash alpha, and here what? 1 plus En f double dash alpha upon f dash alpha up to infinite number of a term minus 1. So if you consider only one term in a first term, so if we consider only first term, then what will happen here? What is the relation between En plus 1 and En? En plus 1 equal 1 by 2 En f double dash alpha. F double dash alpha divided by what? F dash alpha. So alpha is a root, alpha, so f dash alpha is a constant, f double dash alpha is also a constant. So En plus 1 equal, if we write this one, means this one as a constant, this term as a constant, this one is denoted by what? C. So En square, this one is a En square. So sorry, this one is a En square here, this one is a En square. En square. So this become what? C En square. C En square. So if we compare with the standard result, what will happen? En plus 1 equal what? Equal C En square. So again we write this term. Basically here we try to write what? Here we try to write the definition of a rate of a convergence. C En to power k less or equal to this one. This one is the definition of a what? Rate of a convergence. So if we compare this one and this one, we compare these two, what is the value of a k? Value of a k become 2. So what is the rate of a convergence? ROC, rate of a convergence of NR method, Newton-Raphson method. This one is the rate of a convergence of a Newton-Raphson method. What is the rate of a convergence of a Newton-Raphson method? Rate of a convergence of a Newton-Raphson method is 2. Now, here we try to discuss a special case of a rate of a convergence. So, rate of a convergence in general, rate of a convergence of a Newton-Raphson method is a 2. Now, suppose there is a multiplicity of a root. What is the meaning of this one? Multiplicity of a root means at one point there is a 2 roots. At one point there is a multiple root. At one point there is a m roots. Then what will happen? So suppose function is a what? Function is a fx equal, suppose this one is a what? X minus 2 ka cube. So at x equal to 2, how many number of roots? There is a 3 roots. So this one is a multiplicity of a 3. Similarly, if we generalize this one, fx become x minus alpha to power m gx. X minus alpha to power m gx. Now here alpha is a root with multiplicity m. So, and this one is a one factor, so fx can be written as x minus alpha to power m gx. So, what do you think about the f dash x? In this case, if there is a multiplicity of a 2, means fx equal, what is the value of f dash x here? F dash x is a what? 3 term of x minus 2 ka f dash x n minus 1, this one is a 2. So at x equal to 2, what is the value of fx? Fx is a 0. At x equal to 2, what is the value of f dash x? F dash x also equal to 0 because if you put x equal to 2. What is the f double dash x? F double dash x means second derivative. This one is also a 6 x minus 2. 6x minus 2. So at x equal to 2, what is the value of f double dash x? F double dash. So if there is a multiplicity of a 3, then f dash x, f double dash x equal to 0. F triple dash x does not equal to 0. So what is the meaning of this one? If there is a multiplicity of a 3, then second derivative up to a second derivative, the value of the function at x equal to 2 equal to 0. But f triple dash x does not equal to 0. So if there exists a multiplicity of a m, then what will happen? F dash x at x equal to alpha, f double dash x at x equal to alpha. Similarly, f m minus 1 dash x at x equal to alpha is 0. This one equal to 0. This one equal to 0. Now what will happen if the multiplicity of exists in case of a Newton-Raphson method? Now we try to define if the multiplicity of a root exists in case of a what? In case of a Newton-Raphson matrix. So what will happen in this expression? F dash x means f dash alpha equal to 0, f dash alpha equal to 0, f double dash alpha equal to 0, f triple dash alpha equal to 0, and f m minus 1 alpha equal to 0. Now we try to observe what is the rate of a convergence if there exists a multiplicity of a m in general. Maybe the multiplicity of a 1, multiplicity of a 2, multiplicity of a 3, or in general multiplicity of a m. So what is the iterative scheme? Iterative scheme is xn plus 1 equal xn minus f of xn divided by f dash xn. So obviously if the multiplicity exists, then what is the value of f dash alpha? F dash alpha become 0. So directly you cannot apply this iterative scheme until unless you modify this one. So, and one another reason, the rate of a convergence, if there exists a multiplicity of a 1, 2 or mth order, then rate of a convergence of Newton-Raphson method become 1 if we apply the iterative scheme, general iterative scheme of a Newton-Raphson method. Xn plus 1 equal xn minus f of xn divided by f dash xn. Means if we try to find out the relation between en plus 1 and en, means here we write the iterative scheme, try to find out in term of en, means xn plus 1 is a what? Xn plus 1, if we write in term of difference with the actual root, means if we try to write in term of error, then en plus 1 equal what? En plus 1 equal xn plus 1 minus alpha, positive difference, and en is a what? Xn minus alpha, and this implies that xn plus 1 equal alpha plus en plus 1 and xn equal alpha plus en as we defined in the previous lecture. So now putting the values here, en plus 1 plus alpha, and here if we write alpha, this one is the en plus alpha minus f of alpha plus en divided by f dash alpha plus e. Now alpha cancel out, and if we try to simplify this one. Now if we closely observe this one, en plus 1 equal what? En minus, here we write the f of alpha numerator. Here we try to write the numerator. This one is a numerator. What is the value? This one is the expression. So we try to write, there is two expressions, so we write down here. En plus 1 equal what? En minus, now Taylor series expansion. This one is the Taylor series expansion. This one is about f of alpha plus en f dash alpha plus en square upon factorial to f double dash alpha. Now similarly, if we write en to power m minus 1 upon factorial m minus 1 fm minus 1 alpha plus en to power m upon factorial m fm alpha, and so on. In a denominator, similarly, in a denominator we write what? We write here f dash alpha plus en f double dash alpha plus en square by 2 f triple dash alpha. Similarly, if we write en minus en m minus 1 upon factorial m minus 1 fm alpha, and so on. So there exists a multiplicity of order m, then what will happen? F of alpha equal to 0, obviously, because alpha is a what? Alpha is a root. F dash alpha also equal to 0. F double dash alpha also equal to 0. F triple dash alpha also equal to 0, up to f m minus 1 alpha equal to 0, because there exists a multiplicity of order m. Differentiate one time, then m minus 1, there is a factor of x minus alpha, so if we put x equal to alpha, then this becomes 0. So here we closely observe this expression. So f of alpha becomes 0, this one equal to 0, because alpha is a root, f of alpha equal to 0. F dash alpha also equal to 0. F double dash alpha also equal to 0, up to fm minus 1 alpha also equal to 0. Means these term become what? Become 0. Now these term means before the before this term, what is the differentiation? F m minus 1, m minus 1 is order of differentiation. So all other terms become 0. So what is the remaining expression? This one is very interesting. So all other term become 0. En plus 1 equal what? En minus, this one is the first term, En m fm alpha divided by factorial m divided by, what is the first term in a denominator? En m minus 1 divided by factorial m minus 1 fm alpha. Okay, so if we consider only a first term, first term of a numerator and first term of a denominator, then this one cancel out, and if we simplify this one, then what will happen here? This become what? This become en plus 1. En plus 1 equal what? This become 1 minus 1 by m en. En plus, also there is a second term. So if we simplify this one, then we get en plus 1 equal 1 minus 1 by m en plus en square, the term of a en square. Now this one is a very interesting expression. If we closely observe this expression, only first term. So if m does not equal to 1, if m equal to 1 means this one is a simple expression without any multiplicity. M equal to 1 without any multiplicity. So without any multiplicity, if m does not equal to 1, means m is a 2, m is a 3, m is a 4. So en plus 1, what is the relation between en plus 1 and en, and what is the power of en? This one is very interesting. Here the power of en is a 1. So what is the value of k? If we compare with the standard definition of a rate of a convergence, mod of en plus 1 less or equal to c mod of en to power k. So here this one is a positive difference, this one is also a positive difference. So if we compare these two results, so what is the value of a k? Value of a k become what? 1. So in case of a multiplicity, in a Newton-Raphson method, if we apply the general scheme of a Newton-Raphson method, what is the general scheme of a Newton-Raphson method? Means xn plus 1 equal xn minus f of xn divided by f dash xn. Then the rate of a convergence become 1. But what we claim in a Newton-Raphson method, the rate of a convergence is a 2. So how we improve the rate of a convergence and how we modify our iterative scheme? So how we modify our iterative scheme, that modified scheme, iterative scheme of a Newton-Raphson method is nothing is modified Newton-Raphson method. Modified Newton-Raphson method. Newton's Raphson method. Newton-Raphson method. So why here we modify the iterative scheme? Because the rate of a convergence of a Newton-Raphson method is a 1. In case of a multiplicity, if we apply the general scheme, then the rate of a convergence become what? Rate of a convergence become 1. Because there is a relation en plus 1 equal 1 minus 1 by m. M is a what? Multiplicity of order m. Multiplicity of order m. And power of en is a what? Power of en is a 1. So here if we simplify this one, so suppose there is we multiply by alpha here. Alpha is the one expression. So 1 minus 1 upon alpha equal to what? 0. So this become what? This term becomes 0. Then the rate of a convergence of based on a second term, and there is a term means involvement of a en square. So rate of a convergence become what? Rate of a convergence become 2. So if this expression become what? This expression become 0. So how this expression become 0? So here if we multiply alpha, one constant, and alpha equal to m, then this become what? Then this becomes 0. So here if we write en plus 1 equal to what? 1 minus, suppose this one is a p by what? M en plus there is a involvement of a en square term. So this term becomes 0. The rate of a convergence of a Newton-Raphson method become 1. So if 1 minus p by m equal to 0, that P equal to what? P equal to M. So what is the modified scheme of a Newton-Raphson method? Xn plus 1 equal to what? Xn minus f of xn divided by f dash xn. So here P is a what? P is a M. So it will be multiplied by here what? M. So this one is a what? This one is a modified Newton-Raphson method if function have a root with multiplicity of order M. So this one is a modified Newton-Raphson methods. Newton-Raphson iterative scheme xn plus 1 equal xn minus m f of xn f dash xn, where m is the order of a multiplicity of a root of a function fx. So if m is well known in advance, then this one is the expression. Suppose this one is not known, the expression have a, means a function have a what? Multiplicity of a order m. So what will happen? What is the modified scheme of a Newton-Raphson method, iterative scheme of a Newton-Raphson method? So this become what? Xn plus 1 equal what? Xn minus gxn upon z dash xn, where gxn equal what? F of xn divided by f dash xn. So if we simplify this one, then we also able to write in term of a what? In term of a fxn also. So how we write this one in term of a fxn? This one equal to what? Xn plus 1 equal what? Xn. This one is a xn minus, if we simplify this one, xn, gxn is a what? F of xn divided by f dash xn, and f dash xn here, f dash xn minus f double dash f of xn, divided by f dash xn ka whole square. If we simplify this one, then you close the answer, then this one, this square cancel out by this term, then what is the expression? Xn plus 1 equal xn minus f of xn into f dash xn divided by f dash xn ka whole square minus f of xn f dash double dash xn. This one is a what? This one is a modified iterative scheme. This one is a what? This one is a what? This one is also a modified iterative scheme. This one is also a modified iterative scheme. This one is a modified iterative scheme of a Newton-Raphson method if multiplicity of order m is well known in advance. If multiplicity of order m does not well known in advance, then this one is the iterative scheme of a Newton-Raphson method. Xn plus 1 equal xn minus fxn f dash xn divided by f dash xn ka whole square minus f of xn f double dash xn. So this one is a modified Newton-Raphson method. So what is the need of a modified Newton-Raphson method? Because when there is a involvement of a multiplicity of order 1, 2, 3, 4 up to m, then in general iterative scheme of a Newton-Raphson method, the rate of a convergence become 1. So when we modify the iterative scheme, then the rate of a convergence of a Newton-Raphson method again become 2. So these are the two means iterative schemes. If m multiplicity of order m well known in advance, if this one is iterative scheme, if order of multiplicity of order m does not known well in advance.